This is the introduction to arithmetic and geometric sequences. And the first thing we're going to look at is adding up numbers 1 through 100 and find the sum. There's a famous mathematician, Frederick Gauss, who was asked to do this in second grade or third grade. I don't recall what grade. But the story is that he had a lazy teacher, and the teacher in the class liked to sleep and take naps. So he would have the students do things like this, add up the numbers 1 through 100, and so he could take his nap. So before we start on this, I'd like you to try to add these up, but you have 1 minute, maybe 2, to add these up. So what way would you add these up to be able to do it in 1 minute or less? So you want to try to pause the video and then think of that. A lot of you have heard this story before and you already kind of know the answer, but how do you do it? So get out a piece of paper and try to do this while I talk more about Gauss. Gauss is a German mathematician, and I'm reading from Wikipedia here, who contributed significantly to many fields, including number theory, algebra, statistics, analysis, differential geometry, and the list goes on and on. Matrix theory, optics, some science, astronomy, etc. He came from a poor family. His mother was illiterate, but he was considered a child prodigy. He's also known as the Prince of Mathematicians, or the foremost of mathematicians. He was a son of a poor working class parents, and he figured out his birthday because his mom didn't remember when he was born, and he wrote several papers. And what I wanted to tell you is when he was born April 30th, 1777, and he died in February of 1855. Okay? So, have you had a chance to add the numbers up? Did you decide to group them together or find a pattern? So this is what he did. Basically, he took the numbers 1 through 100, and he might have wrote them horizontally. I'm going to write them down. So he took 1, 2, all the way down to 49 to 50. Then he put 51 here, 52, all the way down to 99, 100. And simply what he did was add these numbers up here. So if you add 1 and 100, you get 101. You add 2 to 99, you get 101. You add and so forth. If you add 49 to 51, you get 101. I should say 101. Actually, it's not this. It's 50 to 51. And 49 to 52 would give you 101. And so forth. Well, how many 101s do we have? We have 50 because we split this into 2. So we have 50 times 101, and that gives you 5,050. Now you can do this with any set of numbers. We had a total of 100 numbers, and we divided that 100 by 2 because we split it up in 2, and we simply added the first term with the last term. Okay, and our last term is that. And that is your sum. Okay, so this is a formula you need to know. That's the sum of when you're adding a list of numbers. So let's say we're going to add 1 through 60. Basically, my n equals 60. My first number, we'll talk about the way we write this in just a minute, is 1. My last number, in this case there's 60 numbers, so if you want to, you could write this as a to the 60th, because that's your last term. And that equals 60, and you simply put in the formula, and we get 60 over 2 times 1 plus 61, 1 plus 60, and that is your sum. So that's going to be 30 times 61, and then you get your sum, which I don't have a calculator here, but you can figure that out. So that's kind of the story of Gauss, and that's called arithmetic sequence, or actually a series because we're adding it. And now we're going to talk about arithmetic and geometric sequences. Okay, so for example, this is going to be called an arithmetic sequence. We have 3, 12, 49, and 192. Wait, is this arithmetic? No, we're on the wrong page. Okay, this is called arithmetic sequence. Arithmetic sequence means it has a common difference. Okay, and the common difference we call D. There it is. And what we're going to do, and what you're going to have to do in class, is you have to come up with the formulas expressed in terms of D and the first term. So I have a list here: 91, 83, 75, 67. It's arithmetic because it has a common difference of -8. In other words, we're subtracting 8 from each term to get it, and then we can go on and on and on. Okay, the symbols are the first term. So when you're talking about terms, you write it as this is your first term, this is your second term, this is your third term, this is your fourth term, and so on to your last term. And that's how you write that. All right? Now, we're going to write this numerically in terms of the difference and the first term. So I'm going to write the first term, and I'm going to try to squeeze this in here. It's kind of hard to do on this, but so basically my first term is 91, and so that's plus the first term. So that's going to be 0 times -8. Okay, so 91 plus 0 times -8, because we're not subtracting yet. Okay, the next one is going to be my first term again, plus 1 times -8, because we're subtracting 8 once. The next one, I'll squeeze it in here, is 91 plus 2 times -8. Let me erase this. So we have 91, I'm just going to squeeze it down here, plus 2 times negative 8. And then this fourth term would be 91 plus 3 times negative 8. Okay, and that would give you 67. So basically what we're doing is we're taking 91 plus n minus 1 times negative 8. Why do I say n minus 1? Because this 1 here, my n, and you see the n here, here's your n. So here my n was 1, but the number here is 0. So 1 minus 1 is 0. Here my n is 2, and this number is 1. So 2 minus 1 is 1. Here my n is 3, so 3 minus 1 is 2, and so forth. So that's how we write it. And now we're just going to use the symbols. So basically we have A1 is your first term plus 0 times D. A sub 2 plus 1 times D. A sub 3 plus 2 times D. And A sub 1, so first term, plus 3 times D. This should be A sub 1. First term plus your common difference. Okay? So I'm going to do this again. It looks a little sloppy. All right, so A sub 1 plus 1 times D. I'm going to just stick it down here. A sub 1 plus 2 times D. And A sub 1 plus 3 times D. All right, so our formula is going to be A of 1 plus n minus 1 times D. And that's your formula for arithmetic sequence. Your nth term equals A sub 1 plus n minus 1 times D. Okay? And you came up with that by using the formulas here. Now I'm going to have this all typed up for you, so it'll look better than this, but you can follow along on your sheet when you do that. The next one we're going to do is geometric sequence. And the thing with geometric sequence is it has a common ratio. So we're doing geometric sequence. All right. And here are my numbers, my common ratio, meaning what do I multiply? What times 3 is 12? What times 12 is 48? What times 48 is 192? So basically you're dividing. You divide the current term by the previous term. So 12 divided by 3, or 48 divided by 12, or 192 divided by 48. And you're just dividing the current term by the previous term. And it equals 4. So my common ratio is 4. 3 times 4 is 12, 12 times 4 is 48, and so forth. Okay, and again, our symbols are going to be first term, A sub 2 is the second term, A sub 3 equals my third term, and A sub 4 is my fourth term. And then we go all the way to the last term. Okay, so we're going to express this in terms of R, common ratio. So the common ratio. common ratio, and the previous term. So the way I'm going to write this is 3, and there's no previous term, so I can't write anything here. Again, I'm going to have to squeeze all this in. The next one's going to be 3 times 4. Okay, I express this in terms of r, my common ratio, and the previous term, which was 3. The next one is going to be 12 times 4. My previous number was ace of 2, which was 12 times my ratio is 4. All right? And finally, we have 48 times 4. And it's just what we were talking about earlier. Dot, dot, dot. And now let's use the symbols. So for the first term, we just have ace of 1 because we don't have a previous term. The second one is going to be ace of 1. I don't know why it keeps dotting like that. Ace of 1 times r. Okay. Ace of 2, this is my second term, times r. Ace of 3 times r. And so basically we have ace of n minus 1. Now n minus 1 means the previous term times r. If this is your current term, then this is a previous term. Okay, now we want to express it in terms of r in the first term. So we always want to have the first term. So what we have is 3 times 4, 3 times 16, and 3 times 64. So this is in terms of r in the first term. All right. And let me write again exactly what that means. So I'm going to kind of move the symbol. So this is really 3 times 4 to the 0, 3 times 4 to the first power, 3 times 4 squared, and 3 times 4 cubed. All right, so that this part really goes with that. Numerical. Okay, symbol-wise, this is going to be ace of 1, because we're using the first term, times r to the 0, ace of 1 times r of 1, or r of 1, the first power, ace of 1 times r squared, ace of 1 times r cubed, dot, 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 dot. All those should have dot, dot, dots. So that's ace of 1 times r to the n minus 1. Because for the n minus 1, remember our n here is 4, but we use 3 here. Okay, so it's 1 less. So we have two formulas here, and our formulas are ace of n, you can use either one, whatever works better, times ace of n minus 1 times r, and we also have ace of n equals ace of 1 times r of n or r to the n minus 1 power. Okay? And before we end with this, I want to talk about just language of the sequences. We've already seen a little bit of it, so if you see something like ace of n, that either means your last term or your current term. Ace of n plus 1 is your next term. Ace of n minus 1 means the previous term. Again, r is your common ratio. and D is your common difference. Okay? And we'll talk more about these in class. And that's all of that.